If you're enjoying this introduction to Revit, make sure you check out the full beginner to advanced level course on my website, s15studio.com. So now our project is set up and ready to go. What I'm going to do now is slowly take you through the different tools so we can start to build a small project. And when we do that, I'll slowly go through all of the different features that we use to model our building. So first thing we're going to do is we're going to go to our wall tool. And the process that we use to use our wall tool applies to absolutely every other command in Revit. So when we select our wall, we're in our architecture tab. When I select wall, the various tools that we need to use that tool will come into our ribbon. So there's our modification panel. And in our contextual tab, in our contextual panel, we have the different tools we use to draw our wall. And for that particular line tool, there's our options bar. So first thing is we'll come to the properties section and we'll look at what different types of walls we have available to us. If the wall components aren't appearing on your screen like they are on mine, there's an issue with your template and the folder locations of your families. So please go back to the start of the course where I show you how to configure that correctly, then close down the project and open it again, and then you should now have these components in your project. So I'm using the UK metric library, and the reason I'm using the UK library and sticking with metric is because the UK library has the most amount of components available to us in Revit. If you're using the Imperial library, then you would use the US library. So there are various other libraries for various countries, but the UK has the most populated library available to us. So within the library, there's various different regulated wall types, and also in our doors and windows and everything else. They've all been created using the regulations that apply to those certain components. Obviously, the UK regulations apply to the UK, but we'll use them as a basis for you to understand. And then whatever country you're currently in, you need to then create your own wall types applying those same regulations. And at the end of this course, you'll be able to do that quite easily. So first thing we'll do is we'll look at the titles of these walls. So first we have wall, obviously, in the first piece of the text. Then it has EXT, which is referring to external. And if I scroll down, we have foundation, internal, partition, site and retaining wall, and a substrate wall. So I'm going to stick with the basic wall for now. Below there we have various other types of walls, which we'll cover later in the course. So next we have the title of it itself. So we have 22 RDR, which is a 22 mil rain screen, 100 BLK, which is a 100 mil block, 50 air, which is our cavity, 30 INS, which is insulation, and 100 LBLK, which is a light block, and then 12P, which is our plasterboard. So it's 12 mil plasterboard. When you create your own wall types, you need to stick with that format, as this is the standard for naming your walls. So if your project was to transfer to another company, another client, they can then understand what you've created. So what I'm going to use today is the external wall type 102 BWK, which stands for brickwork, 50 air for our 50 mil cavity, 45 insulation, and 100 DBLK, which is a dense blockwork, and 12 mil plasterboard. So now we've selected our wall type. Once we've selected our wall type, we then come back up to our contextual panel and we have the various different ways we can draw that wall. First one is the line. So to create a wall with the line tool, we simply click once, move the cursor in the direction that we want the wall to go, and click again. When we click again, we place the end point of that wall, and the wall tool remains active for us to continue placing the wall. To complete the action, we press the escape key. So then coming back to the architecture tab in the wall tool, what I'm going to do is use my scroll wheel to zoom in, and I can explain a few more details of how to draw a wall. So again, when we click once and move across to the right hand side, you'll see there's a lot of information on my screen. So we have a lot of drawing aids to help us draw a perfectly straight line. Revit will automatically draw that at 0 degrees. If you move your cursor slightly up and down, you'll see that the wall won't change angle. But if you go further beyond, then you'll notice that it will start to change angle. And instead of manually typing in an angle, what we can do is we can just look for the angle we want it to draw at, and then we can click to place. So it's slightly different to AutoCAD. So again, we're going to reactivate our wall tool and click again to place. So when we're drawing our wall, you'll notice there is a blue dimension above the wall. And as I move it, it automatically updates and displays the length of that wall. When we're drawing our wall and we know the dimension or the length of that wall, so if I wanted to draw a 4 meter or 4,000 millimeter length wall, I can move my cursor until it's at 4 meters. If it's a larger dimension, say 40,000 millimeters, if I scroll out, then the length will go in higher increments. And then again, if I zoom in, it'll go in smaller numbers. So now we're going up in 20s as opposed to thousands. We can also manually type in the length of that wall. So I can move the cursor in the direction I want. I can also add an angle if I wish. So if I wanted a 4 meter wall, I'll type in 4,000 millimeters, enter, and there's my wall at 4,000 millimeters. So one of the strong points of Revit is using those temporary dimensions. So within AutoCAD, we had to draw our lines at the correct distance, the correct angle. And then if we wanted to make changes, it wasn't so easy. We had to use various tools to rotate that line. It was never a quick action. You may also lose accuracy, but with Revit, this task is very simple and very quick. So if I draw another wall, so 3,500 mil, that's fine. Press escape to finish. Once that wall has been drawn, if I then reselect the wall, those temporary dimensions reappear. So if I wanted to increase that to 4 meters, select the temporary dimension, press enter. Now the wall is a total length of 4,000 millimeters. If I wanted to add an angle to that wall, at the end of the wall are tiny blue grips. All I have to do is click, drag, and move the wall to the angle that I want. So on the screen, the temporary dimension angle is showing 2420. If I pull it around, there's 28 degrees. Let go, and my wall is at 28 degrees, and my temporary dimension has changed because I was moving my cursor, but I can again just add that back to 4 meters. But we can do all actions at the same time. So there's 10 degrees, and I can just pull my cursor out when it's at 4,000, let go, and there is my wall still at 4 meters and at the correct angle. We can also move a wall in relation to another. What I'll do is I'll delete these two, and I'll go back to my wall tool, draw one wall here and another above. After placing these walls, if I'm not happy with the location and I want to move either the lower wall or the upper wall, whenever I select them, you'll see the temporary dimension is there for the length. It's also showing me the distance that that wall is away from the top, let's call it the anchor wall, because that wall will not move, but the highlighted wall will. So it's currently showing that the distance between those two is set to 719.6. If I want that to be a distance of 900 away from the anchoring wall, I'll tap the temporary dimension, type 900, enter, and the wall will shift over to the left hand side to now read 900. I can also lower it down. It's currently showing at 663.4. If I again change that to 900, the wall now shifts down to 900 mil below that anchoring wall. The reason I'm calling it an anchoring wall is because that wall will not move. It's the anchor wall, and the highlighted blue wall is the wall that will move. If I wanted to move that top wall, I'll then select it. It's now blue, and this wall is now that anchoring wall. So if I wanted to move it to the right-hand side, I can increase that to 1200, enter, the wall will now shift over to the right-hand side. I can again move it up and down, 1200, like so. So the temporary dimensions are very powerful, very useful tool, and you're going to use them throughout your modeling process. So these are very important things to get the hang of very quickly. There's also other features attached to them. So underneath the temporary dimension is a small dimension symbol. If you tap it, that temporary dimension turns into an actual dimension. So that is now a physical dimension placed on your screen. So that saves you going to the annotation tab, choosing the dimension tool and placing a dimension on that wall. All you have to do is click, choose the dimension symbol, and the temporary dimension converts into a permanent dimension. And lastly, with the wall, you'll see another option here, which is a flipping arrow. So you can see here we have our external brick, our cavity, insulation, block, and the internal plasterboard. Because our wall has, on the external side, 102 brick, 50 air, 45 insulation, 100 block, and 12 plasterboard. The 12 mil plasterboard is on the inner face. So that's why I know that's the inner face. If I choose to flip, what I'm able to do is flip the wall to the other side. So the plasterboard is now going to be on the other side. And where the flip will occur is on the center location line. So that dashed blue line, it's going to flip across there. So click once. Now my plasterboard is on the other side, and it is flipped across the location line. So again, coming back to the wall command, coming into our draw panel, and next over is the rectangle. Simple, just click once, drag, click again to place. And what we've done is we've just quickly created a rectangle shape using the wall tool. All corners will automatically join together, so there's no need for any trimming, there's no need for any joining or anything like that. Everything is done automatically. To then change the shape of that rectangle, we will just select the wall we want to move. And from this point to here is 6690. If I wanted to shorten the wall to say 5 meters, that wall will then pull in. So that wall will then pull in. And where those temporary dimensions are lining up to, it's lining up to the inner face of that plasterboard. I can also change the position of the lower wall by again selecting it, changing here, let's say 3 meters, and enter. By doing this way, we are able to quickly create the shape of our building. Instead of going around slowly taking dimensions of every position, if we know the basic shape of a house, we can just draw it quickly, then come back later and adjust the positions of the walls to make it more accurate. And with the temporary dimension, if you wanted to take your measurements from the outer face of that wall, just come to the end of the temporary dimension, click, drag, and drop it over to the external face. So we click, drag, and drop it. When you see the outer line become darker in blue, you can then drop it onto that point. So now the temporary dimension is going from the outer face of that block to the outer face of that block. If you wanted to go to the center point of the wall, you click, drag, and drop, and when you get that dashed line, you can drop the temporary dimension to that point, and same with the other side. So we have complete control over our temporary dimensions. Wherever we want to position them, and be able to maneuver this wall into the position that we want it to be. Coming back to our wall tool, next we have our polygons. We have an inscribed polygon and a circumscribed polygon. Referring back to AutoCAD, basically our polygon, which is inscribed, will show on the inner face of a circle's circumference, and the circumscribed polygon will be on the outer face of that circle. So when we select our polygon, we'll come down to our options bar, and here we'll show how many sides we want. So if we want, say, 12 sides, we will change that here. Click for the center, expand out, and click to place. So we'll notice that the plasterboard is on the outer face, which we don't want. What we can either do is go to each wall, select and flip, or we can come back, and when we draw our polygon, we can hit the space bar and we can flip it like that. And when we select a wall, we can also use the space bar to flip a wall. So again, when we're doing that, we can just press spacebar, flip, and now the plasterboard is on the inner side. And the circumscribed is the same, but the radius is to the outer side of the circle. Next tool over is the circle. So what we'll do here is we'll just click to place the center of the circle, push out to any side, and if we see that the plasterboard is on the outer side, we'll press spacebar, expand out, and we can either use the temporary dimension to specify the radius, or we can just look for the radius which we want to choose. So 5,000 is fine for me. So now we have a circle. And when we draw a circle using the wall, it's actually two semicircles together. So if we wanted to just simply draw a semicircle, we draw a complete circle, select the other and delete it. So now we just have a semicircle. Next over is the start end radius arc. So for this one, we choose the start, the end, and then we choose the radius for the arc. Again, these tools are the exact same as we have in AutoCAD, just updated to show in Revit. The others, we have our center end, so we'll go to the center of the circle, choose the end, and then the arc. For the next one, we'll come back to the two walls that we have here, and we'll choose the next one, which is our tangent end arc. So we'll choose center of that wall, pull it up to the center of the next, and it will generate a nice curve between those two walls. So because we're getting an unusual join here, it's because the plasterboard is on the inside and there it's on the outside. So we'll select it, press spacebar, flip it, and now everything is joined nicely together. So for the next one, we'll come to our rectangle, come back to our wall tool, and the next one we have is our fillet arc. So for this one, we just need two walls, adjoining walls. We'll select them, and it will generate a fillet between them. And it will also do the trimming for us. So again, these smart tools save us time having to come back to trim and tidy up. If you're not happy with the radius, you just select it and change the radius. Everything updates nice and quick. Everything's joined together, no time wasted. For the next one, I'm going to come down to the bottom here, and we have our partial ellipse. So we'll choose partial ellipse. So for this one, we can just apply it anywhere. So anywhere on the wall, just choosing 2 points, I can make a nice ellipse. Again, all we need to do is just place it. And then once it's placed, we'll come back, select it, and then we can then change that dimension. So that dimension is going from the center point out to the end point here. So the next one is pick lines. So the pick lines is a very powerful tool that we will use as we progress in the course. This tool is also very helpful when we import a AutoCAD plan. So the AutoCAD plan will be a lot of lines, and what we can do is use the pick line tool to apply a wall to a line. So what I will do is in the architecture tab, we have a model panel and there's our model line. All I'm going to do is just draw some basic lines. So that's the architecture tab, model panel, model line. And go back to our wall tool, choose the pick lines, and then all we do is we look for lines, find them, click, and it will automatically put a wall on that line. So as I said before, this is a very powerful tool. If we import an AutoCAD drawing, all we have to do is find the line, use the pick line tool, apply walls to that line, and it's a very quick process to be able to generate a 3D Revit model from a 2D AutoCAD plan. And lastly is pick faces. This is a very smart dynamic tool that we will use later on in the course when we start to create forms. But in the example that is shown on the screen at the moment, what that is, that shape is called a form. So we're able to generate any shape that we wish, and we can use the pick faces tool to apply a wall to that face. And what I will do is highlight everything that we've drawn and delete it. And just be mindful when you're deleting not to delete the elevation bubbles. If you have, don't worry, we can recreate them, but be careful. Just be careful that you don't delete them at this point. If you have, just use the undo to bring them back. We always want our elevation bubbles on the screen at this point. Coming back to our wall tool. So now we have a good understanding of the draw panel. Obviously, yes, it's very brief what I've shown you, but we're going to develop a project soon and you'll put this into practice. So you'll have a good understanding of how to model with these tools. What I'm going to show you next is the options bar. So the options bar is important when we are creating our walls. So with the options bar, what it does is we can apply standards before we even place the wall, meaning that we can apply a height to the wall. We can apply that location line. Where do we want the wall to be placed? Do we want to draw it from the inner face, the outer face? Do we want to chain, offset, and so on? So the first thing on the options bar is the height. So we have height and depth. To show you the differences between height and depth, what I want you to do is open up an elevation view. So we'll come down to the project browser, expand the elevations, and there's my east. I'm just going to double tap the east view, and this is our elevation view. So down in the project browser, under elevations, double tap east, and we are now in an elevation view. Once we've done that, we're going to go back to level 0. We're going to open up our walls. In the draw panel, we're going to use the line tool, and we're going to have height, and we're going to draw one wall. And once we've done that, we'll go to our east view, and we'll see that our wall, as we drew it on level 0, the base constraint is constrained to level 0, and it's now going above level 0. And if we come back to level 0 again, and we'll go to our wall tool, and we change over to depth, I'm getting a little warning here saying default wall settings will be changed, base constraint level 0, base offset 8000. So yes, we're changing those default settings. So we're in depth. What I'll do is I'll draw a wall parallel to our upper wall, and we can't see it on our plan. So our warning is saying none of the created elements are visible in floor plan level 0 view. you may want to check the active view, its parameters and visibility settings, as well as any plan regions and their settings. So the reason we're getting this warning is if we come back to our east view, we'll see that our wall is actually going below level 0 because we changed our option from height to depth. So the reason we have that option is if we are drawing a basement, anything below ground, we can do that from level 0. Or if we have a feature which is hanging from one level to go below, we can also use that as a tool. So I'm just going to select that and delete it so it doesn't interfere. Come back to our level 0 and again select our wall tool. I've been prompted to save, so I will. First thing we do is go back and change over to height. Ignore the warning. So now we're back in our height. We'll come over to the next section where we have unconnected, level 0, level 1. So we're currently on level 0 and here's our level 0. So when we place our wall, our base constraint is constrained to level 0. And what we want is our wall to be constrained, so the top constraint, to level 1. Because right now it's just free in the air and we have no control over the height of that wall. So currently this wall has no top constraint and it simply has an unconnected dimension of 8,000. So that wall is 8,000 high, but it's unconstrained. We want to constrain all of our elements to a level as we have more control over all of the components in a project. So I'll give an example of how levels and constraints can benefit us. So we'll come back to our wall. We'll change our unconstrained over to level 1. And we're now going to just draw another wall parallel to the one we have below. Once we've done that, we'll go to our east elevation. And there's our wall, which now has a top constraint level 1. So if I select my wall in my properties palette, we have our location line. Our base constraint is level 0. Our top constraint is level 1. Why we always want to constrain our components is quite simple. If you have developed your project and your lower floor is at 0 and your higher floor is at 4 meters, if at any point of your project that level changes, if we were using AutoCAD, it could take us a couple of days to go back over all of our work and lower that level, edit our drawings, and ensure that all of our sheets match that new level. Within Revit, when we constrain our components to a level, we can just change the level height and everything will adjust automatically. So what I will do is I'll select my level, click it again. If I change that to 3 meters, the wall, because it's constrained to level 1, will now reduce down to 3 meters. So I've just saved myself a lot of time going back over all of the walls, everything within my project, and lowering it down 1 meter. But if we notice, our previous wall still remains there at 8 meters as it's not constrained to anything. We'll come back to our level 0 again, back into our wall tool. Next over is the location line. So when we're drawing our walls, our location line is the center dashed blue line. It's currently set to wall center line. We have other options available, which is our core center line. So if I select core center line, you see the dashed blue line is going through the core of that block. When we're talking about cores in Revit, what they're referring to is the structural component of that wall. So that structural block is a structural component to our building. So it could be holding up our floors or our roofs. It has a structural integrity to that. So our current location line is going through the center line of that core. Next is the finished face exterior. So the finished face of our wall is our brickwork. So our dashed blue line is now on the face of that brickwork. So the purpose of this location line is if we have our dimensions of our building, if someone has dimensioned it to the external face of our wall, we would then use that location line to place our dimensions. If someone has taken the dimensions of the inside of the building, we would change over to finish face interior. So now the location line is on the inner face of that wall. So now our dimensions will be correct. So when we create our floor plan, we can be confident that our dimensions will match our survey sheet that's showing our dimensions. We also have core face exterior. So again, that block work, which is our core, it's showing the exterior face of that block and the inner side of the core face. So I'm going to change to finish face interior. And just to explain the core a little bit more, when we draw a wall, if I draw a wall and butt up to it, you'll see that there is an automatically it will join together. So there's my block work. It's going to join and look for the other core, which is this block work here. The reason that the core will look for another core is its structural integrity. So again, the structure of this blockwork attached to the structure of this blockwork, because that is the structure of our building. Everything else is simply just a facing brick. It's our cavity or insulation. So they are not connecting. Again, we'll go back to our wall tool and come over to the next one, which is our chain. So if I turn chain off and draw some walls, every time I place one, it's just placing a singular wall. If we turn chain on, the wall command stays active and we can make essentially a chain of walls. Next is an offset. So when I draw, I have my location line to the finished face interior. So it's to the inner side of that plasterboard. It's currently set to 0. If I change my offset to 1 meter, and when I draw my wall, you'll see there's my location line, dashed blue line, and it's offset up to the finished face interior by 1000 millimeters. I'll come back to 0. And next over is a radius. So if I turn radius on, I'll leave it at 1 meter. And when we draw a wall, and we draw the adjacent wall, they will automatically create a 1000 millimeter radius. So again, I can just quickly draw a exterior of a building and it will generate a 1 meter radius automatically. And we'll just turn radius off. Next, we have join status. We have allow or disallow. So if I have join status on allow, when I draw one wall, press escape to cancel the wall. If I come back and click to the next wall, it will join automatically. So those cores are now looking for the other core and they're joining together. If I turn the join status to disallow and do the same thing, you'll see that they do not join. So this gives us freedom of how we want to model our building. If we had two different wall types joining together and we didn't want the cores to join for whatever reason, which is in your design, you would use the disallow. But we can also do it after we have created our building. So if these two walls were adjoining, we didn't want that to happen anymore, we can select the wall. And we have the two grips, which is our location line. What we do is we'll choose the one at the top, right click, and we can disallow join, and then we pull it back and they are no longer joined together. So even though we have done an action at the start and applied that to the wall, we can always come back and fix it. If we wanted them to then rejoin, all we do is we come back and we have this join symbol. Click it, and the walls will then join together. So we can do that here. Select the wall, click the join symbol, and they're now joined together. So when we go into our wall tool or any command within Revit, we just straight away go to our contextual tab, see what's available to us, make the changes in the options bar, and then we will start to draw. I'll just change the join status back over to allow. So I'm going to highlight those walls we've just drawn, again making sure we keep the elevation bubbles, and we'll just clear our drawing space.